Chapter 2, Understanding the Growth and Development of Children. This is the third chapter and final chapter that I will be covering for Exam 1, because your first exam will consist of Chapter 11 that I've already discussed with you, and Chapter 1 and 2. So, understanding the growth and development of children. We know, and I've been saying since day one, that our primary goal for physical education is to get our students physically active, and we want them to have good health throughout their lifespan. Well, in this chapter, there's research to support the value of an active lifestyle so that they will have optimum growth and development. In order to have a lifetime of involvement in physical activity, a lot of times this may depend on what type of exposure the students have had early on in their lives. What did they participate? Were they gratified during this participation, or were they embarrassed, which would bring on a negative effect? So we want to develop motor skills at an early age in these students, and that'll give them the tools necessary to be physically active throughout life. The high number of overweight youth that we see, or that has increased over the years, the need to develop physical skills so that they can have the tools to be active for their lifespan, their lifetime, and exposing them to the long-term positive effects of physical activity are all examples of the studies that have been cited in this chapter to help justify why we should do at least 30 minutes of PE a day. So this chapter is about understanding the growth and development of children. So let's talk about the growing child. I want you to know growth patterns of children are generally controlled by their genetic makeup, by their genetics. So are they early matures, late matures? We're going to get into that. An unhealthy environment can negatively affect their proper growth and development, but we're going to talk about the maturation patterns that are common to most children. I want you to know while all children follow a similar growth pattern, each child's timing is unique. We're going to see that some advance physically for their chronological age, whereas others mature slowly. And so this chapter is going to help you better understand the children's growth patterns. The growth patterns. Teachers, parents, pediatricians, we all regularly monitor our children to see if they are maturing normally. You have what's called distance curves that plot the height and weight of the child or student on a graph from year to year. And this will indicate the height and weight expectations at a specific age. So that's one way. Another way is to examine their growth patterns by looking at what's called a velocity curve. The next PowerPoint, or figure 2.1 on page 21, actually shows you the growth velocity curve for height. So we can see how much taller a child can be expected to grow from year to year. So what I want you to know is this: children go through a rapid growth period from birth to age 5. Children go through a rapid growth period from birth to age 5. Think about it. During those 5 years, they've gone from 20, 21 inches long at birth to how tall? Some of them are almost 3 feet at 2 years old. So what height are they at 5 years old? So they go through a rapid growth period from birth to age 5. Then when you get age 6 to the onset of adolescence, you see where the growth slows down. Well, when this physical growth is rapid, this is when the student's ability to learn new motor skill decreases. It's harder for a student to learn or a child to learn a new motor skill when they are going through a growth spurt. So, what I want you to know is this. Because the growth rate slows during the elementary school years, age 6 and on, this is an excellent time for the children to learn motor skills. So from kindergarten, first grade to fourth, fifth grade, when their growth is slowing down and there's not a rapid growth pattern in their height, this is an excellent time for them to learn new skills and not be clumsy or off balance or feel spastic. And that's where my soapbox starts, because they are not getting that exposure to learn these new skills while they are in the elementary school years. This is the velocity curve for height that I was talking about earlier. And if you notice at the very bottom of figure 2.1, what you're looking at here, you see the age or years at the bottom. So birth would be the vertical line up and down. And then you see 1, 2, 3, 4, 5, 6, all the way to 19. So that's their age. So if you notice, it says centimeters per year at the top. So we would have to convert centimeters to feet. What is it? I'm trying to remember. Why do I want to say 2.2 centimeters is equivalent to, what is it? 1 foot, 1 yard. I'd have to look it up. I'd have to Google it. But if you notice, look at the drastic velocity change from birth to 5 years old. It's a drastic change, whereas it levels off from 6th grade. It's kind of level. There's no drastic downward spiral like you see from birth to 5 years old. And that's why I said earlier, that's when they're going through that rapid growth spurt. So it's the velocity. It's not the actual inches or feet that I'm talking about. It's showing how much of a difference in their growth from birth to 5 years old, how rapidly they grow in their height compared to 6 to 12. There's hardly much difference because it's almost a horizontal line. There's no drastic up or down in the line. Earlier, I was talking about the distant or growth velocity curve for height. Now what we have here is, on the left we have the boys and on the right we have the girls, but this is for their weight, stature for age and weight. So it's not, they also have the height in inches as well. So let's look at the boys. What is this all about? This is where you can tell what percentile at a certain age, you can tell where your child falls into play. So if you know your child's height or height and weight, anywhere for a boy between the ages of 2 and 20, you could look on the left and notice it says IN for inches / centimeters. So now I see here 100 centimeters is approximately maybe 40 inches. Okay, so that's the stature, that's their height. So if you know a child's between 30 inches up to 62, 63 inches on the left, you look at that there. And then how tall are they? So if they're 5 foot, or like I know some of my grandchildren are short, so they're not even 3 feet at 2 years old. So let's say one of my grandsons is 30 inches at 2 years old. So if I look there, he's not even in the 0 percentile, because all those black lines that are going upwards, the very bottom line is 5%. Then you have a black line that's 10 percentile. Then you have the 25th percentile. Then you have a bold black line in the middle that represents the 50th percentile, if he were happen to fall in there. So as a 2-year-old, if he was around 35 inches tall, they're saying he's in the 50th percentile. But if he's around 32 inches tall as a 2-year-old, he is in the 5 percentile at 2 years old. And you can watch and see where they fall. So you're going to percentile per 100. So if we were comparing 100 children that's 2 years old, he would be taller than 4 kids because he's the 5th child, and then the other 95 would be taller than him at 2 years old. So this is for boys. At the bottom, you see the word weight to the far left. So if I knew his weight, and I know he's tiny, tiny, so I know he's not even, be lucky if he's 30 pounds. So if he is 30 pounds at 2 years old, that dark black line in the middle means he's at the 50th percentile. So there's 50 boys weigh more than him and 49 that weigh less if you're looking at 100 boys. And that's what percent means, per 100. On the right, all this pertains to a female. Same idea. You would take their weight, if they're any height or weight, analyze it, see where they fall on this percentile chart. Some of you may have seen this at a pediatrician's office. This is what they do to determine their percentile ranking of how much they weigh and their height. Let's continue with these growth patterns that they're talking about on page 21. In the first column, that second paragraph, they're talking about how during adolescence, that children grow rapidly until reaching adulthood. So I want you to know in the elementary school years, boys are generally taller and heavier compared to the girls. So think about it. Look at the boys compared to the girls in the PE classes, or maybe your own children, nieces or nephews. And do you see that the boys are taller and heavier? But then they say girls reach adolescence growth spurt first, growing taller and heavier during the 6th and 7th grade. I saw that with my set of twins, niece and nephew. They were a boy and a girl. And the girl grew faster, and the boy, poor thing, he was a lot shorter than her. But then she quit growing, and he passed her up in high school. I also want you to know that they're talking about this growth spurt is likely tied to girls reaching puberty earlier. They're saying the average age when girls reach puberty has decreased, and that's true. Unfortunately, I've heard some girls are already starting puberty in the 2nd grade. They are suggesting that I want you to know research suggests that this increased rate of childhood obesity, because they are more obese at a younger age, especially the girls, this may lead or has led to the earlier onset of puberty in girls. I've heard due to the hormones that are put in the grass for the cows to eat, for the chickens to eat and produce eggs, and cows to produce the milk. These hormones are getting into these girls' systems, and that's what's causing early puberty. So there's all kinds of articles out there. The National Center for Health Statistics has developed growth charts that we are about to talk about, or I'm about to show you on the next slide. But for right now, I want you to know we talked about boys growing taller and heavier, and the girls and such. But I want you to know about this business of being top heavy. Because K through 2 students have short legs in relation to their upper bodies, and you'll see what I'm talking about on the next slide, or on figure, let's see what it is, figure 2.4 on page 24. We're about to discuss that. Because they have short legs in relation to their upper bodies, they are considered top heavy and fall more easily than adults do. So K through 2 kids, and so we're not going to fault them for falling. They have a higher center of gravity. The high center of gravity lowers with maturity. So these K through 2 children They're top heavy. Look how big their head is and stuff. And this is why K through 2 children struggle with push-ups and sit-ups because of being top heavy. And that's heavy to pick that up. If you notice on figure 2.4 here on page 24, they show the height in inches on the left, and then they show the gradual yearly or sections of growing in their lives. So at 2 months in the fetus, look how big the head is compared to the rest of the body. Then when they're born, the head, as you see at the top, it says from conception to birth, the head is the fastest growing structure, completing 70% of its total growth. 70% of its total growth. So the head doesn't grow too much more after birth. Then from birth to 1 year, the trunk is the fastest growing, accounting for 60% total increase in height. So when you compare the trunk and the head, that's 2/3 of the total height of this particular individual. Back on page 21, it's saying how the head makes up 1/4 of the child's total length at birth. I knew there was somewhere where it said it. So the head is 1/4 of the child's total length at birth. That's huge. So we talked about birth to 1 year. Now 1 year to the onset of puberty, what's the fastest growing? The legs, accounting for 66% total increase in height. The longer puberty is delayed, the greater the leg length. So if a child, think about it for yourself. When did you start puberty? Earlier, later? Do you have long legs if you started later in life? Some say yes, some say no. Then from puberty, or they show in here pre-puberty to adult. Trunk again grows rapidly, accounting for 60% increase in height. So it's an interesting diagram to give us some perspective. On page 21, at the bottom of page 21, they talk about body physique. Another term for body physique is somatotype. We're going to talk about 3 major physiques and the difference between the 3. But what you need to understand is how these 3 physiques affect their motor performance, the student's motor performance, the child's motor performance. So mesomorphy, ectomorphy, and endomorphy. On page 22, if a child has a mesomorphic body type, what does that mean? They usually perform very well in activities requiring strength, speed, and agility. You need to know the difference between these 3 body physiques. So a mesomorph has a predominance of muscle and bone. The way I remember it, keep your ems together. Mesomorphy, muscles. So they have a lot of muscle. The ectomorph, I want you to know, is extremely thin with a minimum of muscle development. And we characterize an ectomorph as a skinny. So the K sound for skinny and the hard C sound in ectomorph, that's how I keep those 2 together and able to remember the difference between the 3. So ectomorphs are our skinnies. What are the ectomorphs good at? They're good at aerobic endurance activities like jogging, cross-country running, track and field, but they are not as proficient in activities requiring strength and power compared to your mesomorphs. Your 3rd body physique is endomorphs. So I want you to know they are considered to be our soft and round students with an excessively protruding abdomen. Some people call these endomorphs tubbies. I don't see that term anywhere in the book anymore. So I want you to know the overweight children, the endomorphs, are generally at a disadvantage in all phases of physical performance, all phases. So we need to be more sensitive about the body types and expecting the endomorphs to do the same amount of work, for instance, in push-ups, compared to the ectomorph. The endomorph has to raise a lot more pounds compared to the ectomorph, so the endomorph is going to struggle. And we'll soon learn that we will want to use time for when doing push-ups for third, fourth, fifth graders. Instead of saying you need to do 10 push-ups, we will allot them maybe 30 seconds to do push-ups because the endomorphs are working harder than the ectomorphs, and the endomorphs may not be able to do the same number of push-ups compared to the ectomorph or the mesomorph. Skeletal maturity. We know that the physical maturity of a student greatly affects a student's performance in physical education. I want you to know the definition of maturity. Maturity is usually measured by comparing the chronological age, which means how many days, months, and years, how old are they, with their skeletal age. So you compare the chronological age, like how old are you? How old am I? That's your chronological age. And they compare it with their skeletal age. Well, what is skeletal age? Skeletal age is when you look at the hardening of the bones, their skeleton. That's called ossification. And ossification occurs in the center of the bone shafts and at each end of a long bone where the growth plate is. So I want you to know the rate of ossification accurately indicates a child's skeletal age. A child's skeletal age. So the skeletal age is a true measure of maturity. And how do we identify that? By x-raying the wrist bone or a long bone to see like if they possibly broke one of the long bones in their legs, or you think they broke their ankle. When they x-ray the ankle, they can see that growth plate near the ankle and see how much of a growth plate is left. And that's why they're so concerned about not having the break anywhere near a growth plate. So I want you to know, a child whose chronological age exceeds her skeletal age, a child whose chronological age, how old are they, exceeds their skeletal age, they are said to be late or slow matures. Late or slow matures. If a child's skeletal age exceeds their chronological age, they are labeled as an early or fast mature. So if skeletal age exceeds their chronological age, then they are labeled as an early or fast mature. Now you might be thinking, what does this have to do with PE? Well, if you turn to page 24, studies have examined skeletal age, and it consistently shows that if you look at a typical classroom, I want you to know the students display a 5 to 6 year variation in skeletal maturity. I want you to know a 5 to 6 year variation in skeletal maturity. Well, what does this mean? Let's look at the class of third graders. Most of them are 8 years old, chronologically. But if we use that range for skeletal age, then they're actually having a maturity of 5-year-olds to 11 years old. Huge difference. Huge difference. So if you're asking these 8-year-olds to engage in activities, some of them are performing it like a 5-year-old, and some of them are excelling like an 11-year-old. But they're all 8 years old chronologically. So children of both sexes who mature early are generally heavier and taller for their age compared to the average or late matures. Overweight children, your endomorphs, are often more mature for their age compared to normal weight children and carry more muscle and bone tissue. Some of you may argue with these points because you're comparing it to yourself or your children. However, what I want you to know, overweight children also carry a greater percentage of body weight as fat tissue. So this makes them less efficient and decreasing in their motor performance. And we knew that the endomorphs would have a difficult time with motor skills. They're saying the more mature boys usually perform better on motor tasks. Then if you go on, it says girls' motor performance seems unrelated to physiological maturity, but there's two findings that suggest that I want you to know that the motor development follows a different course for boys than for girls. The late maturation is commonly associated with exceptional motor performance. Do you know some really good athletes where they late matures? That's basically what they're saying here, that they are late matures. The late matures are exceptional athletes. Also, the next paragraph talks about students that do not mature at the same rate and are not similar levels of readiness to learn. You'll see on the next PowerPoint, they're all the same age, but their heights and weights are totally different. So what does this mean in reference to PE? I want you to know we need to offer a wide spectrum of developmentally appropriate activities to make sure that our children will succeed, that they will be successful, regardless of their maturity, regardless of their skeletal maturity. Here is the picture of all these children are the same age, but look at how they vary in their size and their maturity. We see some ectomorphs, the skinnies. We see some endomorphs. And I'm guessing some of these are mesomorphs. They have a lot of muscle. But by the way, some people can have a combination of two of these, okay? Or it doesn't mean they're totally this. And you're probably thinking about yourself and looking at yourself and thinking, which one am I? So you can have a combination of the two.